Yesterday we talked about relations in mathematics. I told you that just like in life, you have a lot of different types of relations in math as well. Okay, you have a relationship with your parents, you have a relationship with your friends, you have a relationship with the guy you buy food from at McDonald's, you have a relationship with me. Okay, they're all different types of relationships, and in math we also have that. We have lots of different types of relationships. But in algebra, we're going to focus on one special type of relationship called a function. Okay? I want you to think of a function as like a boyfriend-girlfriend type of relationship. Okay? What makes a relationship a function, and you can see up here on the board, is where there's a relationship between two different things, and every input has only one output. Every x has only one y. So it's important that you guys remember and focus on the fact that every x only has one y. It doesn't have to go the other way, okay? The y's can have as many x's as they want, but every x number can only be paired up with one y in order to make it a function. So when talking about functions, it's important to remember that there's different words that we can use to describe our input and output values, okay? In each problem, they're gonna be different. An example could be like you're going shopping and you're buying pants. The number of pants you buy, that would be your input, and how much money you spend, that would be your output, okay? You would take however many pants you bought, multiply it by however much each pant cost, and then the total amount of money, or when you multiply those two things together, it would be the total amount of money that you have to pay in order to buy the pants. Okay, it's going to be different in every single problem, and this is something that we're going to go over into more detail later on. But for right now, I want y'all to understand that there's a lot of different ways of saying input and output. So in algebra, one way of saying input is calling that the x value. Whatever it is you're putting in, whatever it is you're starting with in the problem, that's going to be your x number. Okay, like in the example I just gave you, that could be pants. Or if we're talking about how much water is left in a pool when you're draining it after so much time, then time is the x. Okay, that's what you're starting with, is a certain amount of time. If we're talking about, I don't know, I can't think of another example. How many cups of flour do you need in order to bake some cupcakes? So how much flour you start with would be your x, and how many cupcakes you end up with would end up being your output or your y. So the input, whatever it is you start with, is your x. We call that our independent variable. Okay, it's independent because you start with it. It doesn't really matter what you do with it. Okay, with the flour, I could make cupcakes, or I can make cookies, or I could bake a loaf of bread. There's a lot of different outputs I can end up with that flour, but no matter which one I choose, it's still flour, okay? It's independent. It doesn't have anything to do with what happens at the end. So our x thing, or whatever we start with, is always our independent variable, and then we consider whatever answers that is, like how much flour I used, or how much time it took, or how many pairs of pants I bought. That would be our domain. And domain and range is something that we'll talk about later on. For our outputs, different ways that we can describe the output would be that it is the y value. The output is our answer, okay? That is what we end up with. That's the final product. That's how much money it cost, or how many cupcakes we made, okay? The answer is always our y. Okay, and most times in algebra, when you're doing problems and stuff, you're gonna have y equals something, something, something. That's because y is the answer. That's what we're looking for. That's what we're trying to solve. that y, or the output, is the dependent variable, okay? It is dependent on what is happening here, okay? Without the flour, I can't make the cupcakes, okay? Without going shopping for the pants, I can't spend the money on them, okay? So the answer always depends, or the output always depends on whatever's happening with the x value or the input. So the answer always depends on the x. It's an easy way to remember it. And then all of our y answers, like how many cupcakes did I end up making, or how much water was left in the pool, or how many pants did I, or how much money did I spend, those answers would be our range. All the possible answers for the output. So, one more time, real quick, just to recap. Input, x, independent variable, domain. Input, independent variable, I'll go with x. Output, y, dependent variable, range. Those things are all interchangeable. I could use any one of these four words and they mean the same thing. And as well as on the top, any one of these four words all mean the same thing. So now that we have talked about what a function is and the two different parts of a function, the independent and the dependent part, now let's look at examples of functions so that you can tell the difference in the multiple representations that we use in algebra. So remembering that a function is a relationship between two items where every input or every x number is paired with only one output, that means that each time that we work with a problem or a math expression or an equation or whatever, each x number can only have one answer. Okay, an x can't have two answers. That's what that definition means. An x, whenever you put an x number into a problem, it can only end up with one answer. So let's look at the 5 different types of ways that we represent stuff in math and see which one is a function or not. So we have a set of ordered pairs, and you can see in this set of ordered pairs there's 3 different points, and each point has an x and a y number. Okay? All you want to do with a set of ordered pairs is look at the x values. If all the x values are different, then this is a function because each x only has one answer or only has one y. In this example, we see that there is x is 3, x is 5, x is 7. They're all different. The y numbers don't matter whether we're trying to determine if this is a function or not. The only thing that matters is the x values. An example of something that is not a function would be below it, where you can see we have 3 points again. We have the point 3, 1, 5, -5, 3, -11. But you can see that right here we have 2 x values of 3. That means that the number 3 in this problem has 2 different y answers, or 2 different outputs, 1 and -11. This would make this not a function because the x's repeat and one x number, and that's all it takes is just one x number has more than one output. Next, we have a table. Here's an example of a table that is a function, where again, we're only concerned about the x values. As long as all the x values are only paired with one y or one output, then it's a function. You can see here we have 3 different x values. What their y values are really doesn't matter. The only thing that's concerning us is that there's different numbers in the x column. So an example of a table that would not be a function would be one like this, where even though all of our outputs or all of our range numbers, all of our y numbers are all different, the x numbers repeat. There's going to be 2 different answers for when x is 3, and there's 2 different answers for when x is 5. So this would not be a function. Next, we have a mapping. And again, a mapping, just like a set or a table, you want to make sure that each x is only paired with one y. In a mapping, we use arrows to connect x values and y values together. So you want to make sure that each x, or each input value, only has one arrow going from it. You can see that in this particular example, we have the 3 has only one arrow going to a y number, the 5 only has one arrow, and the 7 only has one arrow. This would be a function. Each one of those inputs, each one of these x numbers, only has one y value or one output that it's paired with. An example of a mapping that's not a function would be right here, where you can see that this x value, the 3 and the 5, are both going to more than one thing. They're paired with more than one output. They have more than one answer in that problem. So this is not going to be a function because each x value is not paired with just one y. Example of an equation that is a function or not. The easiest way for you to remember that equations are functions or not is to look at the y. I know that a function is where every input is paired with only one output, but as long as your y is to the first power, so it doesn't have an exponent on it, then this is going to be a function. Okay? So this equation right here is a function because no matter what number I put in for x, I'm only going to get one answer for y. Doesn't matter what number I put in, any number I pick for x will only give me one y answer, so this is a function. An example of something's not a function is when the y has an exponent on it. Okay, so there's going to be multiple numbers that I can get. There's multiple x numbers that will give me an answer to this problem. Squaring the y means that you're going to have two different y answers for each x value in the problem. So as long as there's no exponent on your equation, then that means that it's going to be a function. So function, no exponent on the y, not a function, exponent on the y. And then finally we'll look at a graph. So on a graph, we can tell if something's a function or not by using the vertical line test. Okay, if we can draw straight vertical lines through a graph and it only touches it once, and I'm using my finger to represent that, then that means it's a function. So drawing a line through here means it only touches at this point. Drawing a line through here, it only touches at this point. Drawing a line through here, it only touches at this point. So as long as each x number, and that's why you're drawing a vertical line, because each vertical line is an x number on the graph. This would be 1, 2, 3, 4, 5. Then that means that each x is only paired with 1 if it touches it just once. Example of a graph that is not a function would be right here. A circle where if I were to draw a vertical line through the graph, it would touch it at this point and this point. So where x is -1, it has this y value, whatever that number is, and it also has this y value, whatever that number is. So that x number has two different y values, making this not a function. And you can even see this using the y-axis. This is where x is 0. So where x is 0, it has this y value, which is +3, and this y value, which is -3. Making it not a function because that x has two different outputs. It has two different answers with it.